Right, on to our final question then. And this was one of the key reasons that we actually got into some of this research in the first place, because the RFE profiles that you see are over the whole acceleration phase. And one of my concerns in particular when starting to use these, when we were interested in the very start of a sprint, the early acceleration phase, was whether those RF abilities that we were getting from that whole profile were actually quite biased by abilities later on in the acceleration phase because of the relative number of steps that were occurring towards that end of the acceleration phase. So this question was about how well we could use the simple model outputs. So not only from data over the whole acceleration phase, but also when fitted with the simple mono exponential velocity time profile, how well do they correspond to early acceleration performance? In short, very well. And actually with the RF max measure that you can obtain from the simple macroscopic model, for both the block starts and the standing starts separately, there was a near perfect correlation between that and early acceleration performance as measured by the average power production over the initial push-off in the first 4 steps. So clearly the RF max measure gives us a very good picture of someone's performance level. It's a clear performance determinant, if you like. But also as well, if we are in the field and obtaining these profiles and getting the RF max measures, we can have that as a pretty good idea of someone's early acceleration abilities. And we can have confidence that that measure isn't biased by what they do later on in the acceleration phase. So even if they complete a whole acceleration phase, that value does give us a good picture of their early acceleration abilities. Now we do just need to apply a couple of caveats to this, and we discuss these more in the paper. We've used gold standard ground reaction force data here, which has given us a lot of confidence in the internal validity of our data, but perhaps some checks do need to be done on whether these relationships still hold true across other data sources, although we would expect they do based on some of the comparisons that have been done with the velocity time profiles obtained from other devices such as timing lights or laser in some of the other studies. And also we've got these from a cohort of reasonably well-trained sprinters, as you'll see in the paper. But again, we need to be perhaps checking whether these also correspond to athletes from different populations, such as more highly trained sprinters and also team sports athletes.